welcome everyone, and thank you so much for coming to my talk. It's the end of the conference, and I'm sure you heard a lot of interesting things today, and previous days. So I really hope that the last session of today will be a nice addition to all the interesting things you learned throughout the conference. So my name is Justina, and I came here all the way from Berlin, where I work as a head of developer relations at Rasa. So at Rasa, I work as a developer advocate as well. So what I do is I not only write code and contribute to Rasa's open source software, but I also pretty much own the developer education. So I make sure that developers not only have the tools to build great conversational AI assistants, but they also understand how they work and everything that is under the hood. Before joining Rasa, I worked as a data scientist in video games industry for a few years. I just fell in love with natural language understanding and chatbots and open source, and Rasa was a perfect company for me to join, and I'm really happy that now I get paid to work on things that I really loved beforehand. So I will be talking about how you can build your own contextual AI assistants with open source tools and machine learning. And so what Rasa does is we build open source software that developers can use to build their own conversational AI assistants. So if you wanted to build your own Alexa, Google Assistant, or anything like that, I hope that after this talk you will have Rasa as one of the tools in your toolbox that you might want to use to build your own assistant. So just to quickly introduce Rasa and what we care about, so three main things. We do care about open source. So again, Rasa is a company that is developing open source software. So what we aim is to empower developers around the world to build AI assistants without compromising on the flexibility of their tools and without using black box tools. So basically understanding how things work and being able to change things and adapt the frameworks to the projects that they want to use. Community as well, because since Rasa is open source, we want to build community not only about Rasa, but around conversational AI field as a whole, because it's a really interesting field and emerging field. So hopefully you will join Rasa community afterwards as well. And applied research. At Rasa, we have an entire team of researchers that are working on really interesting topics. But what we always make sure that this research somehow then ends up into a piece of code or some kind of tool or a feature in our software that developers can actually use. So we want to make sure that things that we are working on go beyond just the research papers. So as a result of all the effort that we put into developing Rasa, we have developed an open source framework, which is called Rasa. And this framework consists of two main components. So one of them is Analia component, which basically allows your assistant to understand what you ask for, what you need. It's a component that allows developers to build machine learning models that help your assistant to understand user inputs from unstructured human language to structured data in terms of intents and entities, where intent is pretty much overall intention of what the user's input was, and entities, which are important details that help an assistant to understand better what you asked and then also act on it. And also they help to keep the context and remember what specifically the user asked to make the conversations more natural. And second component is called Core, or Rasa Core, which is a machine learning-based dialogue management system. So it's important to enable your assistant to not only understand what you want, but also to decide how to respond. And this is what Rasa Core is responsible for, to use machine learning and real conversational data to decide how an assistant should respond to a specific state of the conversation. And lots of details come into the decision of how to respond. Things like context, so what has been asked before, also current state of the conversation, what the user asked at the moment, and also it can be a bunch of other details that an assistant collected throughout the conversation. We'll dive into them in a second. So why Rasa is different and why developers use it today and why you hopefully will try out Rasa as well. So first of all, it's customizable. So as I have mentioned, it's important to make sure that you can adapt the framework to your own projects. And with Rasa, you can see all the code that is under the hood, all the algorithms that are under the hood. You can tune, and you should tune the hyperparameters of ML models that are behind Rasa. And most importantly, if you need something that is not yet implemented in Rasa, you should be able to build on top of it, and we aim to make it as easy as possible to add custom components on top of Rasa. So for example, if you would like to have a sentiment analysis component within your assistant, you can quite easily do that already with Rasa. So also, Rasa is open source and free, so you don't really depend on specific company. In this example, it would be us, Rasa, to build all the features for you, and you are, again, you are free to see everything that is under the hood and improve things. So if you need some new feature right now, you don't want to wait for someone else to implement the feature for you, you can do it easily with Rasa. And also, it empowers developers. So if you are new to machine learning, if you are new to Python, and in general conversational AI field, you can still build good contextual AI assistants with Rasa. But if you are ML expert, you can have a lot of fun customizing the framework and playing around with machine learning that is under the hood. OK, so now I would like to dive deeper into how building an assistant with Rasa looks like. And actually, I will try to make my session a little bit more interactive. So I will use a proper specific example. So you will see me switching between my slides and the actual example. So hopefully, it will give you a better understanding of how building an AI assistant with Rasa actually looks like. So if you wanted to build an AI assistant with Rasa tools, this is the simplified architecture of how your assistant and application would look like. So obviously, you would have users asking for something. For example, here, it asks for an address change. And the first layer that this message would go through is a connector module. And this is where you have a choice of what kind of messaging or voice platform you would like to use as a front end. So just a few examples. It can be Facebook Messenger, Slack, your own custom UI that you built and would like your assistant to use to communicate with the users. So connector module simply takes user inputs and passes them to the backend. And the first component in the backend is input module, so-called ears. And this is where Rasa NLU model stands. And it takes those user messages in a simple human language and extracts structured data in terms of intent. So what is the overall intention of the user's input? And also entity. So those important details that help an assistant to then better understand what the user asked and make specific decisions of how to respond. And those details extracted by NLU model are passed to a machine learning-based dialogue management system, so-called BRAIN. And this is where Rasa core model stands. And it predicts how an assistant should respond. That's at that specific state of the conversation. It can also take some additional details when deciding how to respond by getting some details from backend integration. So for example, it can be some kind of database that an assistant connects and extracts some data or makes API calls and so on, and uses those details to make a decision on how to respond. And then once the dialogue management makes a prediction of how to respond, it passes those details to the output module, so-called mouth. And output module is pretty much responsible for creating a response in a simple human language that then, again, humans can understand, because obviously, under the hood, everything is a very different format than words and sentences. And then again, connector module is responsible for sending those responses back to the user and showing them on the screen or pronouncing them if it's a voice assistant that you're building. But there is one more component which is very important when building AI assistants, and often this part is left out, though it's very, very important, which is closing the feedback loop and making sure that your assistant constantly learns. So if you build an AI assistant, you want your assistant to get better and better the more people talk to it and the longer you have it running in production. And it's actually not that easy to do if you want to do it yourself and implement this system from scratch. You can either use reinforcement learning, which is also quite a challenging thing to do, especially in natural language understanding field. And what we did at Rasa is that actually we built a new tool, which we released quite recently. It's called Rasa X. So it's designed specifically for that. It runs on top of Rasa NLU and Core, and it takes care of making sure that your assistant can learn constantly from the conversations that it gets from the users. So it works in a quite similar cycle. So you deploy your assistant in production. You allow real users talk to your assistant. You collect conversations that an assistant has with the users. And you as a developer, you then can check what conversations users have with your assistant. You can correct the mistakes, and then pretty much add those new conversations to the knowledge base of your assistant and use them to improve your bot. And then a new improved model is shipped to production, and the cycle continues. And that's how it should be working all the time. So, okay, so let's say you want to build an assistant with Rasa, but you have no idea where to get started. You have no data to get started with. And what do you do? So the quickest and the easiest way to get started with Rasa is a very simple function called Rasa init, which basically was built for developers to kind of use as a quick start. So what it does, it creates a project, Rasa project for you, and then you can see how everything looks under the hood and use that as a quick start for your own project. So I will actually do that myself. So I will show you then how everything looks like. Let me just make it bigger. So I have, again, I have nothing. I want to build a Rasa assistant. So what I do, I simply type in Rasa init. Obviously, you have to have Rasa installed on your machine first. And what it does, it creates a Rasa project for me. It will also have some training data for me and all the main files that I would need to build an assistant. What I can do is I can simply provide a path where I would like to create this Rasa project, and I can call it, I will call PyBay assistant. So since it's a new project, obviously it doesn't exist on my machine, and now you can see it was just created on my computer. Since it comes with some example data already, it also actually builds an assistant for me. And that assistant is a very simple bot called MoodBot. And the main goal of this assistant is to ask how you feel. And if you're unhappy, it tries to cheer you up with a cute picture of a tiger cub. So I can actually show you how this conversation looks like, so then you can understand better of what is happening, especially in the later stages. So simple conversation. So I will start with hello, and an assistant asks, hey, how are you? So I will say, I am sad. And it says, here is something to cheer you up. Since everything is my command line, I will just have to copy this, and I guess I'll have to, leave my slides. It's very important to show you, and it shows you a cute tiger picture to cheer you up. So basically, this is a simple conversation that you can have with the assistant that is automatically built for you. So now I will just leave the conversation, and what I would like to show you are the main components of the Rasa project that you would need to build an assistant with Rasa. So there are a few things that you would need. Since everything is based on machine learning, obviously you will need some training data. We will look into how that data looks like in a second. And then there are a configuration file where you configure the models, NLU and dialog model, and domain, which I will also quickly show you, which basically it describes the universe of where an assistant lives, operates, and describes all the details that it needs to know to make sure that it works and understands what the users say. So this is the structure you can just take and use and continue your development, or just spend some time playing around. So now what I will do, I will actually go through each component one by one, and we'll get back to this example to show you actual specific examples. So when you build an assistant, first thing that you need is to enable your assistant to understand user input. So you need an NLU layer of your assistant, and Rasa NLU is the component that will help you do that. So the goal of Rasa NLU is to take unstructured inputs in an unstructured format, in a simple human language, and extract structured inputs. So for example here, a user, you can see that the user wants to order a pizza, so assistant has to understand that intention of that input is order pizza, and also there is one entity, large pizza, so it's useful for an assistant to remember that detail, and then when it's time to make an order of pizza, an assistant should already know like what preferences the user had about the specific order, and actually go ahead and make an order for the user, and not to ask the same details once again. So how that works under the hood? Actually, there are quite a few ways to achieve that. I will cover only one of them, which is the latest addition to Rasa. It's called Supervised word vectors from scratch approach. So the main idea is that an assistant learns word embeddings. And with this approach, an assistant learns those embeddings from scratch using the data that you provide your assistant. And it's a ranking model, so it simply learns embeddings for user inputs as well as intents, so those labels. And once the new unseen user input comes in, it calculates the similarity between that input and all of the intents. And after optimizing the loss function, it produces the most probable intents that should be assigned to that user input. So also this model was inspired by Facebook research, and there's a paper, Starspace, which I really encourage you to look into because it has some really interesting details about the model and approach of using ranking models for that. But the main advantage of using such approach, and especially learning word vectors from scratch, is that it allows you to build language agnostic assistants. So since you don't use any pre-trained word vectors, which usually come in specific languages, you can build an assistant in pretty much any language that can be tokenized. But you can also build your own tokenizer if you want to build assistant in a very specific language. And also, because you don't use any pre-trained word vectors, you can build assistants in very specific domains, because the challenge with pre-trained word vectors is that they are usually trained on quite generic domains, and then it's really difficult to build assistant in a specific domain for your own product or things like that. But with this approach, since you only use the data that you provide your assistant, and it learns those embeddings from scratch, very high chances are that your assistant will be able to handle quite rare words and specific vocabulary. So another NLU component is entity extraction. So in a very similar way how it works, we tokenize each input. A token will probably be a word in a sentence. And then we use a feature extractor, which extracts specific features from those inputs, and we feed them into named entity recognition model, which produces the specific result, where which word in a sentence is an entity and what kind of entity that is. So basically a label of that entity. So more specifically how that works, I have a very simple example here. So let's say the user asks, what's the weather like tomorrow in Berlin? And the model that is used by default in Rasa is called Conditional Random Field Model. So this model works in a very similar way as skipgram model, which looks not only at the target word when making a prediction, but also at the surrounding words to decide if it's an entity or not, for example. So the result of this model is as follows. So which word in a sentence is an entity, and also what kind of entity. So for example, there are two entities in this, could be two entities in this example, tomorrow, which is a date, and also Berlin, which is a location. So it might be useful for an assistant to know that information. So how it works. So let's say tomorrow is a target word. But as I said, conditional random field also looks at surrounding words. So it looks also at the word before and the word after. And then we extract features from each of those words. So for example, those features can be, is the word lowercase, is it a title, is it an uppercase word? From the target word, it will look at things like, is it a bias word, is it a really rare word in a vocabulary, what is the prefix, suffix, is it a digit, and so on. And then obviously, in a training stage, you will have labels, so an assistant will learn that specific words with these specific features are entities and so on. And then once the new unseen input comes in, an assistant checks if there are some features that it recognizes and extracts entities from unseen inputs like that. So before talking about the dialogue management, I want to quickly go to this actual example that I started previously and show you how now everything works in practice. So to build an NLU model, you actually need two things. One of them is data, and another one is the actual model. So I will quickly show you how this data looks like. So here it is. Maybe let me make it a little bit bigger. So it's quite simple. You need labeled data, and that labeled data consists of the label of the intent that you would like your assistant to understand. So for example, if I would like my assistant to understand how users would say hello, greetings, and so on, I create a label for that intent, for example, greet, and provide a few examples how the user would say those specific things. So a few examples how a user could say hello, for example. And then if I want an assistant to understand how to say goodbye, I do the same. Very important. Since it's based on machine learning, you don't have to write all the possible ways how the user would say hello or goodbye and so on. You need some training data to get started, and then once an assistant learns patterns, it will start to generalize on unseen user inputs. So basically, this is how training data looks like. There are a few intents for this mood bot to understand. So if you wanted to add a new thing for your assistant to understand, you would simply add a new intent to this training data and a few examples of how the user would say that specific thing. So this is the data format. And another thing that I said that is needed for an NLU model is model configuration. So like how this model will look like. So configuration file here is where we define the model that will be used by Rasa. So two important things. One is that you can either use pre-built pipelines that we already pre-made at Rasa to make it easier for developers to build assistants, but you can also build something yourself and pretty much define the entire pipeline of like what will happen when the user input comes in. So how features will be extracted from those inputs, what classifier will be used, and anything else, and your own components that you would like to add. So everything will be specified here. For this simple example, what is created with Rasa in it, we get a pre-built supervised embeddings model, so the one that I mentioned that learns word embeddings from scratch. And that's it. That's pretty much two things that you need to build a simple NLU model. So now let me just quickly show you what is the result of the NLU model and how it looks like in practice. So I think Rasa shell NLU should work. So it should load NLU model for me, and I should be able to test it on some inputs that I would like to see how the model performs. Yeah, so NLU model is loaded, so now I will just type in the simple message, for example, hello, and this is the result of the NLU model. So you can see it's at the bottom. So the message that I typed in was hello, and first thing that I get from NLU model is intent classification results. So in this case, the model predicted that what I said is a greeting with specific confidence, 97%, well, almost 98%, so pretty confident prediction. Also, if there were any entities in my input and the model extracted them, they would be listed here, but since there weren't any and the model didn't think there are any entities in my input, I get the empty list here. And then the last thing that I get from from NLU model are the predictions for all the other intents that I had in my training data. And then, for example, I can see that the model was very confident that hello is definitely not a goodbye because confidence is 0. There was a slight chance that it could be mood happy, so user saying that, hey, I'm very happy today, or affirming, saying yes to something, and so on. So it's a really useful information to have, and especially when you debug and evaluate how your model performs. But this is how it works. And one more important thing that I didn't mention is that you don't have to use NLU and core together. So for example, if you only wanted to build an assistant using NLU component, you can do it because you get all of these results here, and then you can use something else for dialogue management, for example. But if you wanted to use rasa core as well to do dialogue management, this is what I'm going to talk about now. So first of all, why would you want to use rasa core for dialogue management, and why machine learning? You can use, which is actually industry standard, rules or state machines. And based on my own experience, it's actually quite easy way to get started and build something that works. So basically write some, for example, if-else statement. So if the user said this, an assistant should respond with that, and so on. However, things get really complicated very quickly when you want to build an assistant that can actually handle a little bit deeper conversations and an assistant that doesn't fail super easily. What you have to do basically is to write a lot of rules. And then when you have a lot of rules, things get really tricky when you want to debug, when there are some issues with the performance of your assistant because you have to go through the entire architecture of your bot, find where to add this new rule, and so on. So at Rasa, we take a completely different approach from completely different angle. We actually observe how users talk to an assistant. We actually look at actual conversations and then build machine learning model that can learn patterns from those conversations and predict how an assistant should respond. And the main advantage of that is that, especially in the later stages of development, when your assistant is quite big and there are lots of different skills that your assistant can handle, instead of writing more rules, all you have to do is to add a few new examples of the conversations that you would like your assistant to handle. So there is no need to remember the entire architecture of your assistant, and you actually don't need to build any specific architectures for that. So this conversational data that I mentioned a couple of times already looks like that. So on the right-hand side, you see an actual conversation. So it's a conversation between the user and an assistant. It's a hotel booking assistant. And on the left-hand side, it's the same conversation, but it's converted into the rasa format. So the user inputs are expressed as those intent labels that you would have in your NLU training data file, and these are pretty much labels for actions, what the user, what an assistant would say back to the user, and that's it. To train a dialogue management model, you would need at least a few conversations like this. They obviously would have to cover a few different dialogue turns so that your assistant learns different situations and what can happen in the conversation. But this is pretty much all you need. And now just a very quick architecture of how dialogue management works under the hood in Rasa. So we have the user, they ask what's the weather like tomorrow. So obviously NLU model is important because this is how an assistant understands what is the current state of the conversation. So it does intent classification and entity extraction and passes them to the model, which by default in Rasa core is a recurrent neural network. In a very, very, very simplified description of what RNN is, it looks not only at what happens right now in the process that it tries to predict, but also what happened previously, and uses that information to predict the next action or the next step or whatever the model is being used for. In Rasa core, it looks at the conversation states, and first the model gets previous states, and this is where developers can actually define how many steps an assistant should remember when making a prediction. So it can be 3, it can be 6, it can be 10, depends on how long your conversations are and how complex they are. But then once it gets those previous states of what has been said before, it gets the current state of like what the user is asking right now. and uses that information to predict the next best action, so the response that an assistant should make. And also, as I said, sometimes an assistant can use some backend integrations to get some additional details. For example, get some information from APIs or database and so on. And those details that an assistant extracts, it can also influence the next predictions of responses. It really depends, again, on what kind of conversations and situations you want to model. But one way or another, at some point, obviously, then an assistant will generate the response and pass back to the user. So that's a very simplified architecture. And now I will quickly, before covering the last part, show you how the training data looks like once again. So in this example here, I will have just a few training stories, so they can be short, they can be long, depends on, like, again, what kind of conversations you would like your assistant to learn from. So for example, here I have this happy path. So the conversation starts with greet intent. The user said something like hello, then an assistant responded with utterance greet, which probably means that an assistant responded with something, hey, how are you doing? And the user said something that they probably feel happy because it's a mood great intent. And then an assistant said something that also made it happy because it's an utterance happy. So as you can see in this training data file, I have a few training stories, as we call them. And again, an important thing is that those conversations that you use to train your assistant, they have to be quite diverse. So if you use the same conversation over and over again, so for example, if I would copy this happy path 10 times, this is the only thing that, it's gonna be the only thing that my assistant will learn. So to make sure that your assistant starts to generalize on unseen situations, you have to have at least a few different training examples here. So that's the data. And then one more thing that is very important to build your assistant is a domain file, which is basically where you define the universe of your assistant. It also gets created for you with Rasa in it. So here you define everything that your assistant has to know to work. So it includes intents, so what intents your assistant should be able to understand. So it's simply a list of all the intents you have in your training data. And then important thing that I wanted to show here are templates. So this is where you can define how an assistant will respond when specific action is predicted. So what we have learned about AI assistants is that sometimes it's a lot easier to create templates for those responses rather than building an NLG model, for example. But if you want, you can obviously build the model that will generate those responses for you. But a quick and easy way is to simply define what happens when the utterance greet, for example, is predicted, so that an assistant should respond like, hey, how are you, and so on. So just to cut some time, I will, since I showed how a conversation with an assistant looks like, I will dive into the third part of an assistant, which is closing the feedback loop and making sure that your assistant learns over time. So there are two ways how you can do it with Rasa. One of them is you as a developer can use a so-called interactive learning, where it's basically speaking to assistant, and assistant, instead of immediately providing responses, will tell you what it thinks, like how it understood your inputs, and also what it thinks how to respond. And then you as a developer can provide feedback at every step and say that, like, hey, sorry, it's wrong what you predicted. You should have predicted this or that instead. And your assistant can learn from that feedback. Another way to improve your bot is, as I have mentioned at the very beginning of my talk, is to actually give your assistant to real users as soon as possible and let them talk to your bot and collect those conversations and use that to improve your assistant. So very quickly, I will show you how that works in practice. So the tool that is used for that is RasaX, which is built on top of Rasa Core and NLU. So I will quickly launch my assistant in RasaX, which should take just a few seconds. OK. So it's a simple UI also, so non-technical people should also be able to use it. So one thing that is important here is, so the model that was trained at the very beginning is running now in production, as you can see. So what I want to do is I want to give my assistant to real users. With RasaX, it's actually really easy because I can simply generate a link to my bot, which I will very quickly do now. So I generate the link to my assistant, I copy it, and let's imagine I share it with my friends. And this is what they see once they click on that link. It's an actual chat UI, so you don't have to build it yourself, and people can just simply talk to it. So let's say I'm a user, I have a conversation with this bot. So it says, hey, how are you? I am very sad, and then it tries to cheer me up, and so on. But the best thing about all this is that then you can actually see all those conversations and as a developer make improvements. So as you can see, this conversation that I just had with an assistant now is in the conversations tab of the Rasa X. So what I can do is I can actually go through this conversation and improve it if I see that there were any errors that my assistant made. So let's say here it predicted that it's a mood unhappy intent, but let's say it was something else. So I can very simply correct this mistake by simply clicking on this message and correcting the intent and so on. And there are lots of other different improvements and things that you can do, but I will not have time to show you all of them. But one thing that I do want to show you is that once you make the improvements and you add those improved conversations to your training data, which will be done for you, if you, for example, correct something and then save those conversations, you can train a new model with those improved examples that you just added. And then once the training is done, it will, the model will be added to the models tab, and then you can very quickly choose a new model in production. So now you can see I have two models, and then I can add this new model in production, and the users will not even notice that there were some changes in the production model. Okay, so what I would like to encourage you to do is to play around a little bit more with Rasa, but because I'm short on time, I will share some of the takeaway points with you. So just a few important things that I've learned by helping developers to build conversational AI assistants with open source tools is, first of all, make sure to give your assistants to real users as soon as you can, because they will always surprise you, and you will learn so much, things you probably didn't even imagine that your users will ask your assistant. And it's a really nice way to collect a lot of training data and make sure that users help you to build best assistants you possibly can do. Also, start small. It's easy to go over the top and start building your assistant by training it to be able to handle 20 different skills. I would suggest focus on one or two, make sure that they are handled really well, and then build on top as you go. I don't believe there is one tool or one algorithm that fits all the use cases. So I would definitely encourage you to leverage open source tools that are out there, which allow you to change the frameworks to really adapt to your problem and make sure that you can solve your problems with the tools that you have. And even though I was speaking about machine learning and the power of machine learning throughout my entire talk, what really matters at the end of the day is that you build best AI assistants that you can, and that users that use them have the best experience. So sometimes it actually makes sense to have some business logic on top of all the ML framework that you have. So sometimes combining the two approaches is the best outcome that you will get. So also there are some ways of adding rules in Rasa as well. Okay, one more thing. So we will have a developer summit quite soon here in San Francisco. If you want to learn more about Rasa, make sure to join it. And today, actually, we are having a Arousal Community San Francisco get-together. So it's at 6 p.m. just after the conference. If you want to join, I really would like to see you there. I will be there. Some more Rasa people will be there. So you can actually join me if you want to just go there together. It's quite close to the venue. And get in touch. We are hiring. If you would like to join our company and work on really interesting and quite challenging problems in a conversational AI field, come talk to me or send me an email. And if you have questions about anything I said today, feel free to drop me an email or find me on Twitter. I'm really happy to chat to anyone who is interested in the same topic. Okay, thank you so much for listening.
We have room for some questions. If anyone has them, I can bring the mic by.
Hi, it was really interesting talk. So for understanding like the natural language understanding, do you all have like a base embedding that the model, the Rasa ships with, so that if there are similar words, it can identify if they have a similar meaning, at least to get the model started, and then as you use it more, you update the embeddings or something like that?
So not exactly. So the only thing that we have right now is this kind of quick start with rasa init that I showed you, so which already kind of gives you some training data to get started. But we are looking into ways to make it easier and maybe have some kind of crowdsourced data that we could share with the community, and hopefully we will get there. Yeah.
Are there any pre-trained models to take care of stuff like SQL queries?
Great question. With pre-trained models, not that I know of, and we don't really have that in Rasa, but it's possible because I actually built a bot myself, and that's how I actually got into using Rasa, so by building an assistant that can handle SQL queries. But it's handling a query is something that actually happens when an assistant understood what you are asking and predicted how to respond. So it's actually quite easy to do with Rasa because you can implement as backend integrations, as custom actions. So it's possible, but it's not something that is kind of pre-trained for you. Yeah.
So I have a two-part question. So first part is, how do you run in production? I've noticed it was like Sanic server. So do you just do like Daphne or like G Unicorn?
Well, when you want to run something in production, I would definitely suggest using Docker. So we have Docker images. So yeah, that's pretty much a standard to go with.
So this doesn't actually send any data to Rasa, right? It's all self-contained inside.
Yeah, that's also a great question. So yeah, we don't get any data whatsoever, any conversations, anything that your users have with your assistant. Everything runs locally on your machine. So all the data that is involved somehow with your assistant stays on the server, on your local machine or your own server where you deploy your assistant. So it's quite secure.
You mentioned it a few times, but if you had it on screen, it flipped by very quickly. Could you show where a call out to business logic was and what that looks like?
So business logic, so it would happen pretty much in this stage, actually. So by business logic, I mean that, for example, if you know that at specific...
No, I mean the syntax, like what it looks like in the code when you do it.
It's actually quite simple and way simpler than you think. I don't have all full worked out example because it's not really created with Rasa in it. But mapping, it's pretty much a model called mapping policy where you can define that if the user said this specific thing, then this intent should be 100% all the time connected with this specific action. So regardless of what happened before, what's the context of the conversation, that specific action will be predicted. So this is where you define the model, and also in the domain file, you would simply define that if this specific intent, for example, affirm, is detected, then it should the action that comes after this intent should be specific action that you want to define.
Hi, Justin. So you showed a screen where the user was choosing the options and for the model to learn better. So I assumed that was reinforcement learning.
So you are probably speaking about this.
So yes, but also on the slides where there's a phone and 3 options.
Yeah.
Right. So can you talk about specifics of that, or?
Yeah. So it's not exactly reinforcement learning. It's basically what is happening here is that once you correct a mistake, for example, if instead of greet there should have been something else. It's a new story that is being created under the hood, and that story is then automatically added to that training data that you had, and the model is being retrained once again, and then you have a new model that then can run in production. So this is how it works right now.
And is the old conversation that was wrong, taken into account and this was a wrong outcome, or is it eliminated completely?
So if the conversation that had some issues, it will be eliminated, especially if you correct it here with rasa x. But the one that I showed you in my slides, but it's the same approach, interactive learning, is that conversation is being created as you go, as you talk to your bot,
right.
and then if a prediction that was made is not correct, and you correct it, then only the correct one obviously will be used in creating that new correct conversation.
Awesome, thank you.
Okay, I think that's it.
I'm happy to answer any other questions afterwards.
Yeah, I
as
think
well.
so if you want to ask questions outside, yeah, but remember the lightning talks start in 5 minutes.
Yeah, okay, cool. Thank you so
Thanks.
much.